So it was not. I can't open my mic. It was showing some error.
Oh,
I
okay.
messaged you also.
You messaged me, but
Mm,
I checked it, but I think that this was from your issue from your laptop. That's why you're not able to. I don't think this is from our sides, okay? So
okay.
I'm saying that is okay. So you can text me here. Are you not able to
I
text
text
me?
from I text from both sides.
But I'm not able. Okay, let it be. Let it be. Now you are able to speak now. So what is this?
Yeah.
This is compass. This is rectangle. And then after the rectangle, we are going to have.
Where?
Okay. The next one is after rectangle, rhombus, then rectangle, and after rectangle, we have what?
A square and a kite.
Square. Okay. So what is the minimum condition for to prove a rectangle, parallelogram or rectangle?
The opposite sides are parallel to each other and equal.
Okay, prove any two sides are rectangle can be proved. Okay, parallelograms can be proved by opposite sides. Means let me write here the parallelograms also. Okay, a parallelograms can be proved equal if you are going to have either one cases the opposite sides are parallel only. If you proved the opposite side of the quadrilaters are parallel, then it will be considered to be as parallelograms. The second is opposite sides equal. If you prove opposite sides are equal, okay, then it will be considered as parallelogram. Third is any two opposite side, any two, don't prove four, any two opposite side. When I'm writing here opposite, I think opposite, opposite side equal. Any two, not talking about the any two opposite side equal as well as parallel. So if you are just proving that you are having quadrilateral like this ABCD, okay, Rima, look at this and this is an important note. For example, you are having quadrilateral. If this side is equal to this side and this side is equal to this side, if the opposite sides you have proved equal, then don't prove them parallel also. If you have proved only the opposite sides are equal, means if I'm talking about A, B, C, D, so if AB is parallel to DC and AD is parallel to BC, that will be considered as parallelogram. You understood?
Yes.
Okay. Now moving to the next point here is if you have proved for example, this is A, B, C, D, and if you have proved this side is parallel to this side, and this side is, sorry, this side, opposite sides are equal only. Don't prove them parallel now. Just prove them equal. Just prove that AB equals to DC and AD equals to BC. Just prove them equal. Then it will be considered to be as parallelogram. Now the next point is don't prove the two sides equal, the two sides parallel. Just take any two sides and prove them equal as well as parallel. This is AB parallel to DC and AD also equal to DC. If you have proved any two sides equal as well as parallel, don't consider these two sides. Don't take these two sides. Just consider any two sides. If you are having any two sides which are equal, this is 5 centimeter, this is 5 centimeter, and they are parallel also. They are parallel also. Then the quadrature form by joining these two sides will be a parallelogram. Got it? Or you can
Yes.
prove that opposite side angles are equal. So if in a quadrature opposite angles are equal, then it is also considered to be as parallelograms. Okay, so consider this opposite angles are equal. Got it? So
Yes.
when you have taken in out of four things, if you have done any one thing, that will be considered to be as parallelograms. Either prove opposite sides are parallel, AB parallel to CD, okay, and AD parallel to BC. or don't prove parallel, prove them equal, AB equal to DC, AD equal to BC, then it will be a parallelogram. Or take any two sides equal as well as parallel. Means just prove AB parallel to DC and also AB parallel equal to DC. So if don't consider this one. So then it will be considered to be as parallelogram. Now you understood? Alvina, you understood? Turn on your camera.
Yes, sir.
Alvina, turn on your camera.
Okay, sir.
Now moving to the next part here is. Okay. The next part is, now you have proved that ABCD is a parallelogram. Now what you are going to do here is that you have to prove them rhombus. First you have to prove any coordinate. For example, if you are going to prove a rectangle, ABCD is a rectangle, ABCD as a square, ABCD as a rhombus, if you are just going to prove this one. So what you need to do here is just do one thing. Okay. Just prove first ABCD as a parallelogram. At least you need to prove parallelogram, because a square is also parallelogram, rectangle is also parallelograms, and rhombus is also parallelograms. So if you are going to prove them parallelogram, then what you need to do, sorry, if you are just proving a quadrilateral ABCD as a rectangle or either a square or the rhombus, so first prove it as parallelogram. This is the first choice that you need to do it, that you need to prove it first parallelogram, because all of them are parallelogram. And for proving the parallelogram, a quadrilateral ABCD as a parallelogram, you need to choose any one path of them. That is will be given to you according to the data that you have to use. Either prove opposite sides are parallel, either use opposite sides are equal, either use any two opposite sides equal as well as parallel, or opposite angles are equal. So if it is given to you, then it will be considered as parallelogram. Now, for proving a rhombus, what you need to do is, if you are having a parallelogram and you have proved that this adjacent sides are also equal, then it is a rhombus. Means any two sides are equal, adjacent sides, not the opposite sides. If the adjacent sides are equal, then it will be considered as
A rhombus.
a rhombus. Okay. So how can you prove any two adjacent sides equal? So if you have proved any parallelograms, ABCD is a parallelogram, and if any two adjacent sides are equal, like for example, if this side is equals to this side, you have proved, or if you have proved that this side is equals to this side, then it will be considered to be as in a parallelograms. If any two adjacent side, you understood what is Rima? What is adjacent side? You understood?
Yes, sir.
So what is adjacent side?
Sir, the nearby sides. The
Yeah,
sides which are next.
those vertex are forming an angle. Okay, so if this A is formed by this side and this side, so these are the two adjacent sides. If C's angle is made by this side and this side, so this will be considered as adjacent sides. Okay, you understood?
Yes, sir.
Rima, turn on your mic first, Rima. Otherwise, how you are answering, but I am not able to. You understood?
Yes.
Sure.
Yes.
Should I move forward? Or how can you prove a rhombus? Prove the diagonals bisect each other at right angle. If a quadrilaterals ABCD is a parallelogram and its diagonals bisect each other at right angle, then it is a parallelogram. So prove its diagonal bisect each other. Okay. Its diagonal bisect each other at right angle at 90 degree. Okay, so if you have proved any quadrilaters which is going to have its diagonals, either their diagonals bisect each other at right angle or any two adjacent sides are equal, then it will be considered to be as rhombus. You understand?
Yes, sir.
Understood?
Sir, give me 1 second. Now what you have teach?
Okay, I'm saying here that if you have proved this, so for example, this is ABCD is a parallelogram. This is parallelogram that you have proved.
Okay.
Now, if you need to prove this parallelogram as a rhombus, so what you need to do is prove its diagonal bisect each other at right angle. Means this side is equals to this side and this side is equals to this side. And moreover, this angle is of 90 degrees. So if you have proved that the diagonal bisect each other in a parallelogram, if the diagonal bisect each other at right angle, then it will be considered to be as rhombus. You understood?
Yeah. Yes. Understood.
Alvina, you understood? Or either prove any two adjacent side as equal. So you have to prove, if you need to prove a parallelogram as a rhombus, you have to do one thing. Either prove their diagonal bisect each other at right angle or either prove their sides are equal. Okay. Now moving to the next part is, if you need to prove that ABCD it is a quadrant, but you need to prove it as a rectangle. So if a parallelogram's vertex angle, if any angle of a parallelogram is 90 degree, is ABCD, and for proving a parallelograms as a rectangle, you need to prove any one of the angle as 90 degree.
Okay.
Any vertex angle. So because if this is 90, then it will be automatically become 90. And since this and this is going to have the sum of 180 degree, so this will be also 90, because 90 plus 90 is 180. And this is 90, then this will be also 90 degree. So simple is that if you are having a parallelogram and if any one of the angle is, any vertex angle is 90 degree, then it is a rectangle. So what you need to do here is, if you need to prove a rectangle as a parallelogram, what you need to do? Prove any vertex angle as 90 degree, or prove its diagonals are equal. Prove its diagonals are equal. Okay. Got it?
Yes, sir.
Yeah. Should I write
If
it down,
diagonals
sir?
are equal, then in a parallelogram, if diagonals are equal, then it is a rectangle. Okay.
Yeah.
Or the vertex angles are equal, then it is also a rectangle. Now moving to the next part. Here,
Sir, can I write it down?
what you are saying?
I wanna write it down. I didn't write.
Yeah, you have to write it. I have previously discussed this one, but I am just revising because it has been so long that we have discussed these points. For proving a square, what we need to do is vertex angle, either prove vertex angle, angle 90 degree, as well as diagonals are equal. Diagonals are equal. Or you can prove all sides equals, as well as vertex angle 90 degree, or you can prove all sides equal, as well as diagonals are also equal. Diagonals are also equal. So if you are just going to prove anything, anyone, either prove vertex angle 90 degree, diagonals equals. Vertex angle as well as diagonals are equal, and bisect each other at 90 degree. And bisect each other at 90 degree. So please note it down, then we shall be moving to further.
Okay.
Done?
No, sir.
1 minute, sir. Sir, one more shape is also there. A kite.
What?
Under parallelogram, one more shape is there. A kite.
Now, kite is not in our syllabus. I'm going to discuss this one.
Okay.
Done? Done, Rima? Noted?
So 1 minute.
Okay. We'll discuss the midpoint theorem also, but first of all, we shall be going to discuss. Done, Alvina?
Just a second. Last point I'm writing. Under the square.
Okay.
Yeah, done, sir.
Am I noted? Noted?
Sir, last point. Done, sir.
Okay. So do question number 4. ABCD are rectangles in which diagonal bisect each other at angle A and C. Show that ABCD is a square and diagonal BD bisect angle B and angle D. How will you do this one? Draw the figure first. Done.
So, like we have to try to answer it.
Yes. Okay, let me help you. Ravina, will you able to solve
Yes.
this one?
Sir, the first bit I got, I think.
First of all, draw that figure that is being asked to prove. Okay, so it is being asked to prove that ABCD is a square. So try to make it a square. Okay. A, B, C, D, and it is being asked that diagonal AC bisect angle A. What is being given to you? That ABCD is a rectangle. So this side will be equal to this side, and this side will be equal to this side. Opposite side of
Yes.
rectangles are equal and parallel. And it is being given that this angle is equal to this angle because ADAC bisect angle A. This angle equal to this angle. Okay, got it?
Yes, sir.
Okay. Since this angle, this vertex angle is of 90 degree. This is 90 degree and it is bisecting this one. So this will be 45, this will be 45. Or you can say here that if it is X, then this will be also X. If it is Y, this will be also Y.
Yes, sir.
Yeah.
Okay, now this angle is forming Z because these two angles are parallel to each other. So we can consider here that this angle is forming Z here. Okay, so we can simply say here that this angle will be equal to this angle,
Yes, sir.
alternate interior opposite angle, that is forming Z. Okay, so X, if X is equals to Y, so we can say that this is also equals to X, this is also equals to X. All of them will be equal. Got it?
Yes, sir.
So if we have already a rectangle, and what we need to do here is we need to prove that this side is equal to this side, then it will become a square. Okay, so how can we prove? We can write that angle 1, you can write name it angle 1 and then angle 2. Or you can name it as X and Y. It's your choice. So we will set let angle A let angle A is equals to 2 angle X. Then X is equals to angle A by 2. Got it?
Yes, sir.
So actually, I didn't got it.
What are you saying? Angle 2 angle X is equals to 2 angle X this plus this. So you can write that, and you can write angle X is equals to angle Y. Y, or you can write it angle BAC equal to angle DCA. Okay, DCA is equals to angle X is equals to angle Y. Okay, got it?
Yes, sir.
Got it? So if this is X, so this is also X, and this is X, this will be also X because they are equal. Okay,
Okay, yeah.
alternate interior opposite angle. So we can say here that, so we can say that this angle will be equal to this angle. So in triangle this, if this angle X is equals to angle Y, this side this equals to this side will be equal. Why? because this is forming an isosceles triangle. So you can write here that angle DAC, angle DAC is equals to angle ACD or DCA. DAC is equals to angle DCA. Okay, जैसे ये इसके equal होगा, that if this become equal to this one, then we'll say that in triangle ADC is an isosceles triangle in which what you will say, AD is equals to DC. AD is equals to DC. Now you understood?
Yes, sir.
Okay. Okay. So if this side is equals to this side, if this is 5 centimeter, this is also 5 centimeter. And since this is also equal to this one because it is opposite side of parallelogram, so this will be also 5 centimeter. And this is also equals to first. So all sides are equal. So in a rectangle, if all sides are equal, then it is a parallelogram, it is a square. So we will say that since AD is equals to DC, so in a rectangle, if two adjacent sides is a parallelogram, you understood?
Yes, sir.
Understood? Now it is also being asked that diagonal BD bisect angle B and D. You need to prove that. You need to prove that if it is square and the diagonal bisect also this one. This we wanted to prove that this is also equal to this one and this is also equal to this one. So let if it is A, this is B, this is C, this is D, then you have to prove A is equals to B is equals to C is equals to D. So you need to prove A is equals to B and you need to prove C is equals to D. So since this side is equals to this side, why? Because all ABCD is a square. Rima?
Yes.
Since ABCD is a square, okay, so we will say that this angle in triangle ABD, this side is equals to this side because it is a square. Now we have proved. So since the two sides of squares are equal, so this will form an isosceles triangle. This will form an isosceles triangle.
Yes, sir.
So we'll consider that this C and A, okay, will be means
Equal.
this angle will be equal to this angle. C is equals to A. And now you know that C, this is forming Z like this. C will be equals to B. Similarly, this is also forming Z like this. So B is also equals to C. Okay. So we'll
Yes,
write
sir.
here in triangle. We'll write here in triangle ABD. AB is equals to BD. Therefore, triangle ABD is an isosceles triangle. Got it? Got it?
Got it.
Now this is A, this is B, this is C, this is D. Again, we'll write it A, B, C, D. A, B, C, C, D. So you will write here angle A will be equals to angle C because triangle ABC, sorry, ABD is an isosceles triangle in which AB is equals to AD. Second point, you will write that angle A will be equals to angle D. Angle A will be equals to angle D. Why?
Sir, I didn't understand.
Because
Angle
of
A,
their co-interior
angle
angle.
A will be equals to angle D. Why?
Because
It
they're
is
alternate interior. Yeah.
this is forming Z, in which this side is parallel to this side, so this angle will be equals to this angle. Remember, when we are having the two sides like this parallel, then their alternate interior angle, this A, will automatically become equals to this. So we'll write here angle A will also become angle to D. Why? Reason? What the reason behind this is? Alternate interior opposite angle. Alternate interior opposite angle. Okay, got it? The next one is, you will similarly you will write angle C is equals to angle D. Angle C is equals to angle B. Sorry. Angle C is equals to angle B. Why? Same reason, alternate interior opposite angle, because this is forming Z now. Here you can check. Here you can check that this angle is, or this side is parallel to this side, so this angle will be equals to this angle. So now A is equals to C. Now A is equals to C, and C is equals to B. C is equals to B. Okay, and then you have also proved that A is also equals to B. Sorry, A is also equals to C. You have also proved. Okay, A is equals to C, and you need to prove C is also equals to D, because A is equals to C and A is also equals to D. So AA is equals to C, A is also equals to D. So they both will be will be equal to each other. Okay. So we'll write here A is also equals to D here. So if all the angles are equal, then it will be considered to be as. We'll say that A also bisect D. Okay. Sorry, BD bisect angle D as well as angle B. Okay, got it?
Got it, sir.
You didn't understood, Rima?
Sir, I'm not getting it. Uh,
You're not getting it. Okay, let's try one easy question from this portion, the same question. Then we shall be coming back to this question. Okay. Do question number 3. This is PD. Do question number 3 and try to do it by your own.
okay.
Try to do it by your own. Done?
So I'm doing it.
Alvina, you done?
Sir, I'm doing.
Hmm?
I'm doing.
Okay, try to do it. It is easy and simple.
So, like, I'm not understanding what should we prove.
Rima, what are you saying?
What we have to prove?
It is being given that show that it bisect AC, means you need to prove that if it is ABCD is being given to you, that is the parallelogram, show that, and it is also being that given that it bisect A, angle A, means AC is bisecting angle A. Okay, so it is being given to you here that this angle X, so this will be also X, means these both are equal. And it is being given that ABCD is a parallelogram. So parallelogram means this side is also equals to this side, and this side is also equals to this side. It is being given to you. And also parallel to each other. This side is parallel to this side, and this side is parallel to this side. So being given to you. The last thing that you need to prove here is that you need to prove that it also bisect AC. Sorry, angle C, means you need to prove that this angle is equals to this. Means you need to prove Y. Okay, you need to prove this one. Prove it. Vina, you done?
Sir.
Hmm?
No,
No.
sir.
Why no?
It's confusing a little.
Okay. Since this X, mean this side is parallel to this side, means AD is parallel to this side. Okay, so if it is X, then this will be also equals to X. Hmm? You got it? Got it?
Yes, sir.
Similarly, since this side is parallel to this side, so if it is X, this will be also equals to X. Got it? Let me explain you one
Yes.
more time. Okay. So if it is X, this is also X. Okay. It is also,
Yes.
it is given to you. You need to prove that if it is A, that you need to prove. Given ABCD is a parallelogram. Okay, this parallelogram has been given to you, and AC bisect angle A. So you can write it. So you can write it. Now it is being given to you that you can write it. Let angle BAC, this angle. Okay, BAC equal given है आपको DAC equals to X. It is being given to you. Given that it is bisecting in this angle is equals to this angle. It is being given to you. Got it?
Got it.
Then what is being asked? To prove angle angle A is equals to angle B. Now you know that angle X will be equals to, or you can write angle DAC, this angle will be equal to angle B. Why? Alternate interior opposite angle.
Alternate interior. Yes.
Similarly, angle, if you are moving to this one, this angle A will be also equals to angle X. Okay, and okay, so you will write here angle BAC is equals to angle A. Same reason, alternate interior opposite angle. And these two are equal. These two are equal. So this first, this is second. So from first and second, we can write that angle B is equals to angle A. Okay, this take is third. Okay. From first, second, and third, you can say that since these two are equal, so this will be also equal. Got it? Angle B is equals to angle A. So i.e. we can say that angle DCA is equals to angle BCA. Hence proved. What is being asked to you that it is also a rhombus. So how can you, sorry, it is also a rhombus. How can you prove a rectangle as a rhombus?
By proving any two adjacent sides equal, or by proving diagonals bisect each other.
So how will you prove? You are not going to have the other diagonal, so how will you prove it? How will you prove it?
We can prove by showing any two adjacent sides are equal. We can take the triangle DAC and BAC and say that they both are isosceles, so DC is equal to DA, like that.
Okay. 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 So since this is equals to this, we have proved that X is equals to B. This angle is equals to this. We have proved that angle DAC in this angle we have proved that is equals to A. So this side will be equal to this side.
Yes, sir.
So because it is an isosceles triangle, so if any in a parallelogram, if two adjacent sides are equal, so note it down. Say angle X is equals to angle A. Angle DAC, note it down. Angle DAC is equals to angle DCA. Note it down in triangle. In triangle, DAC is equals to angle So in triangle DAC, okay, angle X is equals to, you can write angle DAC is equals to angle DCA. And this angle is equals to this angle. Yeah, prove this one. So you will write here, therefore, AD will be equals to DC. Got it?
Yes, sir.
Now you can write it. Got it? Now this is equals to this. This side is equals to this side. So we can write it AD is equals to DC. So now note it down. So in a parallel graph, if any two adjacent sides are equal, then it is a compass. Note it down.
Done, sir.
Done? Okay. So next is question number. Show that the diagonals of squares are equal and bisect each other at right angle. How can you prove this one? How can you prove this one? Tell me. How can you prove this statement? Rima, try. Show that the diagonal of squares are equal and bisect each other at right angle. Hmm? How will you prove this one? Tell me first. Don't have all day. Okay. Show that the diagonal of squares are equal and bisect each other at right angle. How will you prove this one? So this is a square. Okay. And this is A, B, C, D. Rima, where have you gone?
Yes, sir.
Camera off. So it is a square. So all sides are equal. When this side will be equal to this side. This side, all sides are equal. So you need to prove that, show that the squares, the diagonals of squares are equal and bisect each other. So which triangle, two triangles you need to take? You need to take these two triangles. This we have done in the previous class, but you are forgetting this one. This is very easy. So you have to put the diagonals. So take these two triangles.
Triangles ADC and BCD will take.
BCD. This side is common in both. DC. This side is equal to this side, opposite side of the parallelogram. Sorry, opposite side of the square are equal. And this angle is 90 degree. Each square has 90 degrees. So by side angle side, these two triangles are common.
Yes.
Then by CPCT, AC will be equals to BD.
Yeah.
Now we have proved that this this side is equals to this side. Okay, diagonals are equal. AC is equals to BD. Okay. Now how can you prove that they bisect each other? For bisecting, you need to prove that this side is equals to this, and this is equals to this. How will you prove? Take these two triangles. Okay, wait a minute. Take these two triangles, this one and this one. So you have this side is equals to this side, this angle is equals to vertical opposite. Since these two sides are parallel, so this angle will be equals to this angle. So by side angle or angle sides, angle sides, these two triangles will be common. So by CPCT, this side will become equal to this side and this side will become equal to this side. So in the previous class, we have done this one. Okay. So you need to check this one. Okay. Got it?
Okay.
The last one, and the last one is